I have always been interested in space business, and since I was a kid, at age 14, I had Apollo posters on my wall. This is the successor of that, if you like, and I always felt the motivation to work for challenging project in a space context. This is the 2-axis solar array drive mechanism. It's going to be used on the Orion multi-purpose crew vehicle, or MPCV. The MPCV is regaining access for manned flight for the US, and as part of a big contract, the Europeans, so ESA, builds the service module for this 2-part spacecraft. So we have a service module and a crew module. The service module provides propulsion for the entire spacecraft, so it has the tanks and the rocket engine. It also provides life support for the crew, so it has air to breathe, water. It does the thermal control of the entire spacecraft, and it generates electric power for all the spacecraft systems. The function of the mechanism is to orient the solar array wings towards the Sun around 2 axes. Here, this is the first axis. The second axis drive will be mounted here. And the idea is to point the solar arrays to the Sun to maximize the power generation for the spacecraft. Well, actually, it's the largest solar array drive mechanism we have ever built. The main challenge developing this mechanism was the high loads that are a result of the powered flight. We have to use the powerful spacecraft engine going to the moon and coming back from the moon. So we do 2 things. We fold back the solar array wings, keep them in that position. Still, we have quite high loads emerging from the powered flight. This is why this mechanism has to be quite robust and stiff. The European-built service module will be flown on the so-called Exploration Mission 1. That's an unmanned mission that will go around the moon in 2018, to be followed by a manned mission a few years later. It's a challenging job, and you have to find concepts to solve complicated problems.